We've gone to a system where we can supply power for completely electrifying all the accessories on a transit bus, or any heavy-duty vehicle for that matter. There's essentially 5 systems on buses that are conventionally driven by mechanical means today, and those would be the alternator, the engine cooling, the power steering, the air compressor, and the air conditioning system. With our auxiliary power system, we can provide electrical power to operate those completely electrically. We provide 208 3-phase AC power for the higher powered accessories such as the air conditioning, the power steering, and the air compressor. We also provide 28-volt DC power that we create electronically off of our high voltage system. That eliminates the alternator, powers all of the conventional bus 24, 28-volt accessories, and also does the charging for the vehicle 24-volt batteries. One of the advantages of making the 28-volt power electronically is that we can regulate that much more precisely than a conventional alternator can do. And that way we charge the batteries with exactly the right charging voltage, whether the engine is idling, whether the engine is running at full speed, or even if the engine is off. On a conventional alternator, when you have a very heavy electrical load and the engine's at idle, such as at a stoplight or at a bus stop, typically the alternator can't supply enough power and you're drawing off of the 24-volt batteries for air conditioning loads, lighting, and so forth. The electric engine cooling fans are more efficient than the mechanical fans for a couple of reasons. One, the electric fans, even at maximum power, draw substantially less horsepower than a hydraulically powered or a mechanically powered engine cooling fan. A typical mechanical powered engine fan draws anywhere from 30 to 50 horsepower. The electric cooling fans at maximum load will only draw about 9 to 10 horsepower. The other advantage is because they're electrically operated and thermostatically controlled, the amount of power they draw goes down dramatically when you're at lighter loads or cooler temperatures, so that in the majority of your operating conditions, the electric cooling fans are drawing dramatically less power. They also, at those lower levels, are much quieter than the engine cooling fan if it's mechanically powered. You have an electric power steering pump with a conventional electric motor, can be located in a variety of places on the bus. It does not need to be located in the engine compartment. One of the places that it can be located, if there's room, is up at the front of the bus, right near where the steering system is. This does 2 things. It shortens the very long hydraulic lines that typically run to the engine compartment. The second thing is that it reduces the amount of hydraulic lines that are in the engine compartment, potentially even eliminating hydraulic lines in the engine compartment, and that eliminates the possibility of engine fires from those sources if you get a hydraulic leak. The accessory power system is mounted on the roof. Typically it's mounted adjacent to our propulsion control system, which is the unit that provides all the propulsion power and control for the hybrid system. The APS is also cooled using the same cooling system that cools the hybrid system, so there's no additional cooling or plumbing needed. And the APS is fully integrated with the hybrid system, both from an electrical standpoint and from a diagnostic standpoint. All of the diagnostic troubleshooting, fault codes, and diagnostic software works with both of them. The key piece that enables accessory electrification on the hybrid drive system is our accessory power system. That's the piece that needs to be added on to the hybrid drive system, and it provides the electrical power either with APS level 1 or with APS level 2 to provide the 28-volt power, or to provide 28-volt and 208 3-phase power that can power all of the accessories. So from a maintenance technician's point of view, one of the big advantages of electric accessories, and you can see it here, is that all of the belt-driven components are eliminated out of the engine compartment. On this bus, there's just the belt-driven water pump, so you have one belt left. We don't have an alternator, we don't have an air compressor, we don't have a power steering pump that would normally be located around here. We don't have the very large air conditioning compressor that would normally be located usually somewhere off to one side of the engine. So the engine compartment becomes a much larger, cleaner space that's easier to work in. And by eliminating all the belts, you eliminate the maintenance on those belts, and you also eliminate the danger of those belts if the maintenance technician needs to have the engine running while he's doing some work.